students, we will discuss today with second order differential equation with constant coefficient. Okay, so the general equation is d2y dx2 plus p1 dy dx plus p2y equals to some function of x, where p1 p2 are constant and qx is any function of x. Now see students, if we have this form d2y dx2 plus p1 dy dx plus p2y equals to qx, then we call this equation, I am rewriting it again, d2y dx2 plus p1 dy dx plus p2y equals to some function of x. We call it non-homogeneous equation. And in place of qx, suppose if we have 0, that means d2y dx2 plus p1 dy dx plus p2y equals to 0, then we call it homogeneous equation. Okay, now we will discuss today how to find CF, that is complementary function for the given differential equation. Now see, if the equation is non-homogeneous, then also we are getting this part d2y dx2 plus p1 dy dx plus p2y, and if we have homogeneous equation, then also we are getting this part, right? So if we solve for this part, then we call it CF, complementary function. So see, whenever we have homogeneous equation or suppose we have non-homogeneous equation, we will write the equation first in homogeneous form, that is d2y dx2 plus p1 dy dx plus p2 equals to 0. Now let us take y equals to e to the power mx as a trial solution. Then students, what is dy dx? dy dx is m e to the power mx, and second order differential d2y dx2, that is m square e to the power mx. Let us replace the values in equation number 1. So we are getting m square e to the power mx plus p1 e to the power mx plus p2, it will be m e to the power mx plus p2 e to the power mx, this equals to 0. So from here we are getting m square plus p1 m plus p2 e to the power mx equals to 0. Now from here either we can get e to the power mx equals to 0 or m square plus p1 m plus p2 equals to 0. As I have taken y equals to e to the power mx as trial solution, we cannot take e to the power mx equals to 0, because if I take e to the power mx equals to 0, this has no meaning. So let us take m square plus p1 m plus p2 equals to 0. Now see students, this is a quadratic equation, and for quadratic equation we know that we have two roots, and how many type of roots we will get? We will get three type of roots. First one, suppose value of m is m1 m2, that means roots are real and different, then our CF is C1 e to the power m1x plus C2 e to the power m2x. Now the second type, suppose m equals to m1 comma m1. That means we have real and same root. Then CF is nothing but C1 plus C2x into e to the power m1x. And the third type is, suppose we are getting complex number alpha plus minus I beta. Students, if one root of quadratic equation is alpha plus I beta, then another root is automatically alpha minus I beta. So we will always get alpha plus minus I beta. Suppose if we have this type of root, then CF is e to the power alpha x C1 cos beta x plus C2 sin beta x. Okay, so this how we will find CF for both homogeneous and non-homogeneous equation. Now let us take an example. Suppose we have this equation d2y dx2 plus 3dy dx plus 2y equals to 0. Then we'll write let y equals to e to the power mx is a trial solution. And we know that our dy dx will become m e to the power mx and d2y dx2 will become m square e to the power mx. So students, whenever you get this d2y dx2, in place of that you can directly put m square e to the power mx, and in place of dy dx just put m e to the power mx every time. So therefore I am getting the auxiliary equation as m square plus 3m plus 2 equals to 0. Now if I factorize it, that is m square plus 2m plus m plus 2 equals to 0. From here we get 2 into m plus 2 plus 1 into m plus 2 equals to 0, which is m plus 1 into m plus 2 equals to 0. That gives m equals to minus 1 minus 2. Therefore our CF complementary function is C1 e to the power minus x plus C2 e to the power minus 2x. Okay, let us take another example. Suppose example 2 is this. d2y dx2 plus 4y equals to sin 2x, and the question is asking for find CF, the complementary function. Then students, first we will write it in homogeneous form. So the homogeneous form of the given equation is d2y dx2 plus 4y, that's equals to 0. Now we know that we have to take y equals to e to the power mx as a trial solution, right? So therefore dy dx will become m e to the power mx, and d2y dx2 is m square e to the power mx. Now let us put this in equation number 1. So I am getting m square plus 4 equals to 0. From here we get m square equals to minus 4, that gives m square equals to 4i square, as we know that minus 1 equals to I square. So therefore m equals to plus minus 2i. From here we are getting CF as, see, if I compare it with alpha plus minus I beta, that means our alpha is actually 0 and beta is 2. So therefore it is e to the power 0 c1 cos 2x plus c2 sin 2x, that is e to the power 1 is 1, so c1 cos 2x plus c2 sin 2x. Okay. Now example 3. Suppose students we have this d square plus 2d plus 1 y equals to 0. Now students, what is d square? See, we have talked about dy dx. So that is nothing but d dx of y. Let us take d dx as d. Then it will be simply dy, and d2y dx2 will become d square y. So therefore we have same things to do. So let y equals to e to the power mx is a trial solution. If it is a trial solution, then we know that dy dx equals to m e to the power mx. Okay, so the auxiliary equation will become, in place of d put m, and in place of d square put m square. Okay, you can directly put in place of d m, and in place of d square put m square. Okay, just put this, you will get auxiliary equation. So m square plus 2m plus 1, that equals to 0. So that gives m plus 1 whole square equals to 0, which is nothing but m equals to minus 1 minus 1. Now see, we have same and real root. So therefore our CF is c1 plus c2x e to the power minus x. Okay, today up to this. Hope you find this well. Thank you students. Bye.